Technically, I'm a high school dropout. They kept calling me on roll call every morning for months. I just didn't show up.
At 13, he skipped high school entirely and went straight to college.
Nobody cares about you. You're on this giant campus. That kind of forced me to kind of grow up in some ways. You have to think about where do you want to direct your life and take responsibility for things, which I was not used to as a 15-year-old.
Professor Jonathan Chen, Associate Professor of Stanford Medicine and Director of Medical AI Education at Stanford, leads the Health Rex Lab in the Stanford Division of Computational Medicine, a pioneer in clinical AI integration and the impact of large language models on diagnostic reasoning, holds both an MD and a PhD in computer science, over 100 publications across medicine and informatics, co-founded Reaction Explorer LLC, an expert system for organic chemistry. And outside the lab, he's an award-winning magician, using sleight of hand not just to entertain, but to make complex ideas click.
I got the PhD in computer science so I can work on interesting, fun intellectual problems, but I got the MD to help me understand and focus on important problems related to human health.
Decades later, that combination led him to a discovery he couldn't believe.
Very weird phenomena where human plus computer does worse than the computer by itself on a complex reasoning task. This was not what was supposed to happen. I think we have to rethink a lot of tasks and things we used to assume a human had to be in the loop.
And the stakes couldn't be higher.
Most of the time, the harm is not that it invented, hallucinated some crazy medication or surgery. The majority is it had an error of omission. Doing nothing is not the same as doing no harm. I don't think safety slows down innovation. Safety is what enables you to innovate very boldly and aggressively. I wouldn't have said this out loud 3 years ago. We are clearly heading towards AI doctors, AI computer systems that could just prescribe medicines by themselves. That would have seemed crazy 3 years ago to even say that out loud. Now, to me, it's obvious, it's inevitable.
Because where this is all heading is closer than anyone thinks. I'm Jim. As a founder myself, I learned something about this journey. The best way to build a startup is not to read a menu, but to learn from your fellow founders' stories. Before we dive in, I have a small favor to ask from you. If you find value in conversations in this channel, please hit subscribe button and turn on notifications. It helps us keep the mission going. And this will be the only favor I will ever ask of you. Jonathan, I'm really honored to have you in the founder cohort, and you have a very fascinating experiences. I saw that you went to college in age of 13. That's super young age. How did it happen?
Yeah, it wasn't by design or plan necessarily. I was just a kid. I was a pretty nerdy kid, and I just went to public school. And then when I was around 8th grade, there's a program at Cal State Los Angeles. It actually started in their psychology department, I think, as an experiment to bring young kids in and see if they handle that. But after the experiment, it just kept on going and turned into a sustained program all ongoing called the Early Entrance Program. I took a test, basically something like an SAT type thing, and I seemed to do well enough. They said, why don't you come in for a summer quarter, take some college classes just for the summer, and then hang out with the program to see both academically, but also like emotionally, would you be ready for an experience like this? And then it kind of was. And so me and my parents, and I didn't know necessarily any better. It was like, what a unique opportunity to do something like this. And more or less, I basically skipped high school as a result. So I went straight into that program from there, was there for a couple of years, transferred to UCLA from there afterwards, and graduated from there a few years later. But technically, I'm a high school dropout. Yeah, apparently my high school I was supposed to go to, they kept calling me on roll call every morning for months. Jonathan Chen, Jonathan, are you here? Are you here? No, I just didn't show up. We didn't tell them. I just didn't show up.
And you went to UCLA.
At first, the program was through Cal State LA. Then after 2 years of there, I transferred to UCLA. I wasn't required to. It was just kind of expanding the scope of opportunity. And to give some color there, that was a much more challenging experience. When I was at Cal State LA, it was a program. There's probably 30, 40 kids like me around that age, right? They're all starting college kind of early, but you have this cohort. So although you're taking classes with college students, you kind of have this group of younger kids to kind of socialize with. When I transferred to UCLA, I'm like one 15-year-old kid. I'm living on campus in the dorms and 30,000 people on campus. That was very difficult and challenging, right? It's a very different experience because basically nobody cares about you. You're on this giant campus. Nobody has time to pay attention to you anymore. On the flip side, that kind of forced me to kind of grow up in some ways. I was like, I go to class, I study really hard, and I get straight A's. That's my job, right? And it's like, oh, you realize that's just not enough anymore. You have to think about where do you want to direct your life and take responsibility for things, which I was not used to as a 15-year-old, and I had to learn very quickly.
Yeah, exactly. Yeah. And I think what you mentioned is very resonating to me because I went to college at 16, so similar age.
There you go.
It's like, it's a very lonely experience. Like everyone's like 3-4 years older than you. And did that experience had impact you when you do the career choice, choose your career?
Sure, it definitely did. I don't know about you, but when I was 13 years old, I didn't think that much about what career I wanted. I'm just a kid. I was going to play video games. I'm going to just do stuff for fun. If you had asked me when I was a child what I wanted to be when I grew up, I probably would have said I'll be a stand-up comedian because I like making people laugh. I mean, but who cares? I'm just a kid. Obviously, it doesn't mean anything, right? Or at some point, maybe I'll be an architect to design the dream home for my mom or something. It's just, I wasn't really seriously thinking about it. But now it's like, oh, I'm actually like in college now. I have to actually start thinking about that. You have to pick a major. You have to think about a direction. And of course, it's like my parents, my mom especially wanted me to be a doctor. We have no doctors in the family. And I thought, well, I don't know. I guess that's a hard thing to do and an important thing to do. I don't know any better. Sure, I'll start on this sort of pre-med track. Not necessarily knowing exactly what it was, balanced by the realities, like kind of in my heart personality, I'm really a computer nerd. It's much more gravitated towards that. My dad's an electrical engineer, and that's more naturally from my personality, and I try to navigate that in a kind of messy way, but that was part of growing up too.
Yeah. And I know choosing the major is pretty hard thing. And a lot of times, especially when we are young in college, we have no idea. And so we just follow the choice. Yeah. But it looks like you did some navigation of your journey, and you went to this program that has both computer science and MD, PhD. Is that?
Sure. All the above. It's always the thing. Literally on my med school application essay, I say, maybe it looks like this makes sense, but actually it's a very circuitous route, and we're kind of figuring things out as we go. I did learn, at some point I was like pre-biology or something like this. I thought you had to do that to become a medical student. And then when I realized that was not the case, I was like, I will definitely not major in biology or biochemistry because that's not actually my inherent interest. I have a much more computational interest. So just what's necessary to get towards that direction. So UCLA, I ended up getting a degree in cybernetics with a specialization in computer studies. Now, I think MIT and UCLA are the only places that have this major. You might call it systems biology nowadays. It's all about like computational modeling of biological systems. And that really worked for me. It's like, oh, okay, that's very cool because I get to learn a lot of computational engineering concepts, but also in an applied medical biological domain where that has that direction. And then we're kind of skipping ahead to that part of the story, but I was doing that. I took the MCAT, kind of the test to get into medical school. I did really well on it. I was an officer in a pre-medical club, and I'm there hearing all the time about if you want to be a doctor, it's a huge commitment. You have to want to be a healer. It's your life's passion to do this. But I'm like an 18-year-old kid. Like, I don't feel anything. I don't feel like I'm not ready to commit my life to this direction. This just does not make sense for me to like commit to right now. And so kind of at the last minute in college, I said, no, I'm not going to medical school. I'm not going to go. I'm not even going to apply. And instead, it was actually also right when the .com boom was really starting to happen too, that I got a software job. I was a software engineer, actually my first job right out of college.
So after you graduate, you just went to work and around .com boom era.
Exactly. So I graduated, what was it, 2000? And so then I was already doing an IT job internship. And then I worked for a software company based on Austin, Texas, Trilogy Software, amongst other experiences. And then that was interesting. Oh, that's a really good job in some sense, right? I'm actually very good at programming, and I'm paid well to do it. And then once my parents saw how much I could be paid as a software developer.
And you made more than 6 figures.
My first job when I was 19 years old was 6 figures with a $20,000 signing bonus. And maybe that sounds ordinary now, but this was 26 years ago. So that wasn't that normal back then.
What was your feeling when you got the first check?
I think I gave the signing bonus to my mom. I mean, this is just the behavior of all the support they've given me. And we've always mutually supported each other for all along. So that was cool and validating, like, oh, like I can do something valuable that people care about. But before we get too excited about that, that was good. But also there was this .com flurry, right? Everyone's just throwing money around. Just like there's an AI like buzz right now, and before it was some other buzz. And it's all very exciting, but it also learned me some real tough lessons about life and what industry is like, for-profit industry is like too. When I worked at that company for a year, and it was very exciting. I learned a lot about more technology, working with people, project management, unit testing, optimization, all this kind of stuff. And then I also learned like, a for-profit industry is very mercenary culture. They don't care about anything. And actually, as it turned out, a year later, I got laid off with a third of the company. I got another job like within like a month. It was fine, and it was perfectly okay. But that really shaped my mindset a lot. I'm like, oh, all this stuff I was working so hard on is so stressed out about. And then once I'm let off, like, what does it matter? Like, do I care? I'm over beating myself up too much about it. Like you're working on a business problem. It's perfectly fine, a reasonable thing to do. But that really did get me gauged. I got another job, which is fine. I was good at it. I was appreciated. I was paid well to do it. But to me, it's like, oh, this is a job. I don't know if I'm seeing a long-term career I'm going to feel satisfied, rewarded with. I wonder if I should rethink some things about what I do. I learned other good principles about the really valuable people, even in industry, have strong quantitative technical skills, otherwise it's all just talk and fluff, but who also deeply understand a subject or a business domain. And then to me, I thought maybe medicine, healthcare could be that business domain again. But then my classmate back in undergrad who went on to medical school when I jumped off ship, I was hanging out with him, reconvening. He's like, hey, you ever thought about applying to medical school again? I'm like, oh my gosh, no, I stepped away from that. I'm not going to go back and deal with that again. And he said, you took that MCAT, that test, which I did really well on. It kind of has an expiration date. You could still use it and apply for medical school within 3 years. After 3 years, if I ever applied to med school, I would have to take that test again. I was like, well, there's no way I'm taking that test ever again, because that was really painful to take that test. So maybe I'll think about it. But oh my gosh, I have to go back to my old professors, go beg for a letter of recommendation after I left early. Oh my God, well, I have to deal with all this. It was my girlfriend at the time, though, and I talked to her about it. I was like, oh my God, Jonathan, you should definitely apply to medical. You definitely should. In life, you will regret what you didn't try, not what you did try. I very much remember this line. It's really twisting the knife. And I was like, oh, that really got me. And then I was like, fine. I will apply. I don't have to get into medical school, but I'm going to at least try to do it. However, I'm not going to apply for a straight MD program, because I do know enough about myself that being a full-time doctor, that's just not me. It was never going to be, but it doesn't have to be either. Mm-hmm. I'm going to only apply for programs for joint MD PhD training, and the PhD has to be in computer science. Mm-hmm. And that sounds really weird. Nowadays, it would make a lot of sense. At the time, 25 years ago, it would sound really, really weird.
It's very real. People will associate MD with engineers or technical skills.
So most people will think, oh, you're going to get your PhD in biology, neuroscience, immunology, molecular something. And I was like, those are all fine, but I know that that's not intrinsically me. If I wasn't going to be a doctor, I wouldn't study those things. I would study something else. I would study computational work. So if programs are open to that and they think that's a cool combination and can support me in learning that, let's take a shot. If everyone thinks that's a crazy idea, I don't have to do this. I have a job and I can live a much easier life than I actually have lived. Even though the reality is I didn't know exactly the combination. Luckily, I did find a couple programs that were into it. I ended up going to UC Irvine, Southern California, Orange County, a joint MD PhD program. And very compellingly is they have a school of computer science. Mm-hmm. So usually computer science is housed within engineering. It's like, no, it's an independent school because it's such a big program. And they had another student in front of me, Josh Swamidas. He was 2 years ahead of me. He was an MD PhD getting his PhD in computer science. Most places talked about how they thought it might be interesting, but to have a really concrete example and role model to kind of look to, like, this really could be a thing, that was a very compelling direction. And I like to say I got the PhD in computer science so I can work on interesting, fun intellectual problems, but I got the MD to help me understand and focus on important problems related to human health. And that's kind of started off a very crazy long journey that I don't know necessarily what I was signing up for.
I think fast forward now, like medicine and biology, computer science, they all connect. But back then, 20 years ago,
it sounded weird.
Did you forcing some of these, or do you just like Follow your
I
passion?
had no idea. There's all sorts. I didn't know. I don't know if you guys know what a third or fourth year medical student does in clerkships, a medical residency, a fellowship, postdoctoral fellowships. Also, I actually had no idea what any of that was. But I figured this is good intellectual. I am fundamentally a nerd, and what I realized in industry, it's great for work and projects and making money. But in most settings, it was actually did not cater to curiosity. Hey, I want to learn something. Just go, did you guys read this thing? No, we don't have time for that. Let's get back on project. What is our goals? It's like, all right, fine, just get back to work. I actually really like just being in the school environment. Surprisingly, maybe not surprising. That's why I'm still here. So I don't know. I just like learning. I just like learning. So to be able to have that environment to cultivate that. At the time, was it going to be protein structure prediction or genome analysis? At the time, that seemed like the only way to marry computers with medicine or biological science. Now, we can talk about it in a bit, really combining much more with actual healthcare practices and let alone medical AI applications. It's really unified. It took forever, but it's really collated in something that resonates with me a lot.
A question I have for you is that a lot of breakthrough actually happen in this interdisciplinary area. Someone with very diverse background is kind of misfitting in every place. Like you mentioned, you feel like being a doctor is not a thing for you, but you also feel like there's this weird thing about technology, but you end up figuring out your own path. Do you think that this is a general pattern, or does the school systems or the societies actually encouraging this?
There's clearly some self-selection bias. I have gravitated towards programs that go in that direction. So like huge bias, right? I'm going to have my whole response here. But I did pick that up from my industry experience, even though I have actually a lot of hard feelings about the industry experience that I really was kind of traumatized by it in some sense. I felt being laid off there felt like my first failure in life, but actually just kind of learning how life works. When I went there first as a software company, I'm going to go here. I'm going to be the best programmer there is because I could be so good at it. And then I get there, realize like, well, everybody here's a programmer, basically. How are you going to be the best programmer? There's no distinction anymore. That doesn't barely mean anything. And having that lesson I heard there a couple of times, like the most impactful people are the ones who have this strong, deep technical skill, but who also deeply understand a subject application domain. Now these interdisciplinary things can happen, these crossover ideas, these nuggets can confirm. That actually gravitated for me, and I deliberately set myself with my training to be able to do that in a way. And I'm very biased, but I've set up my research lab in that capacity too. So I have very strong computational postdocs and students, data science experts, right? Everything's become a data science for measuring everything, but also literal doctors, clinicians, scientists, so we can all kind of learn from each other, because not always, but a pretty repeatable pattern is innovation is very often at the interface of disciplines, right? There's a very good idea that's been developed in one area, but just hasn't been figured out or applied in another area. And for better or worse, modern healthcare is typically behind other industries by over a decade in terms of adoption of information technology and the use of real world data. So it's like, well, just see what's really working well in IT, informatics, computational, e-commerce industries, and then how does that analogize to what is needed in a very high-stakes medical area? But it's very easy to say that from the outside. What are the actual medical problems? Or I did a lot of chemistry in my graduate school. What is the chemistry problems needed? I try to really immerse myself and learn it and practice right alongside them to distinguish credible versus non-credible problems.
I know that in your PhD, you built a tool that to help students do chemistry homework.
Yep.
And that became an education platform that you use worldwide. Yeah. Tell us more about that story.
Of course, I went to medical school, got medical training, which surprised me that I wanted to do more of it by the end of it. I did not think I actually hated the pre-medical environment. It's very toxic. It's all about building your resume and competing with other people, that I thought I wouldn't like medical school either. But the end of medical school, you're actually dealing with real patients. It was very compelling to me in a way I didn't expect. In my PhD work, though, in the middle, I got a computer science PhD, but it was very applied to chemistry, organic chemistry. I thought that meant I was going to go work for a pharma company, invent drugs or something like this, or design them. That would be the natural, logical way that would connect. Instead, as a side effect of what I did, in so many words, I built an AI system that could solve organic chemistry problems. It was a complex rules-based expert system. For 2 years, I made 2,000 rules and 5,000 test cases, so that it could basically replicate this type of thinking and reasoning. But if this thing could do your organic chemistry homework, that means it could teach you how to do your organic chemistry homework too. That wasn't what it was intended to do. It just kind of turns out that it was a very natural thing it could evolve into. And so kind of on side, not really intentional, I made it into a platform, a tool, an application that students could use to help them learn, and people really seemed to like it and responded to that. And so even though that wasn't intending, that just grew and grew and grew in impact and influence in our local institution, UC Irvine, at their classes. And then we said, I presented at some conferences. Here's some life lessons about companies as well. Well, I'll just go into the conference. Hey, all you educators, I made this thing. I don't even care about making money. Just please use it. I made it. I'm so glad anyone's using my research. And some people did, but basically free is not the right price. A business can't sustain itself. A product can't sustain itself. It needs a sales team. It needs a marketing team. It needs a tech support team. It needs an infrastructure team. And you need to pay people to do that work. So we ended up licensing out the software, the platform, to a publisher, Wiley Publishing in this case. And then we created a company just for that purposes. Here's some other machinations. I don't know how far we want to go here. But technically, I invented this thing in the university. So I don't own it. The university owns it, right? Stanford has a similar thing. I think UC has it where, well, me and my advisor, we were the inventors, so we own 25% of it, but like the university is going to take 50%, the department's going to take 25%. So even if we sold it to a company, which we did, we get only a fraction of it then. So we basically create this little company with no employees. It's like me and my advisor and one other person to intercept the licensing revenue and then license that to the university so that we basically capture most of the profit before paying a license fee to the university, was how that was structured.
You mentioned about it can solve a lot of the chemistry homework problems, and a lot of students now use ChatGPT to do those tasks, and you did well ahead of time. And back then, when you do these systems, what constraints you faced?
At the time, is I had to understand the actual knowledge area, right? So I took like 2 or 3 graduate level organic chemistry courses, even though that's not my degree. I'm a computer scientist. I was trying to really learn how they think to understand the domain. Because at the time I had to do a lot of work building the representations and encoding the knowledge that I learned and putting it into a form that's computer executable. So program the engine and then the huge knowledge base to kind of power it. So of course now the language models can do a lot of powerful things, but doing it in this kind of visual representation, organic chemistry is not equations. It's all diagrams, basically. Also required a lot of custom work to kind of pull that together.
Yeah, and you also mentioned about you created complaints to do that. And so did you how people to continue working on it?
I mean, that's an open question now. If anybody online would like to reach out and has a thought of where to go, because it was by design, basically a license, right? There was software that I made as a student, essentially. We licensed it to the company that we founded so that we could then license it to a publisher to use it and distribute to students. And that worked for us. It was basically just me doing the technical support work to kind of keep things together. And then the company did almost nothing else, just the basic functions, just to stay operational. And then that worked very well and was very profitable for over 10 years. We just had one exclusive customer. After like the 11th or 12th year, eventually that publisher moved on. And so now actually I'm deciding what to do with this company, if at all, anything. Because we still hold the intellectual property. There still is a very distinctive capabilities it has. But it would take a whole nother sales cycle to regroup and decide whether we find another publisher, market direct to consumers, revamp the product. And it's just tricky because I have so many other things going on with my other research career right now that I haven't quite decided what to do with it.
Yeah, maybe some of our audience would be interested.
Anybody in the audience like to reach out if you'd like to buy this software, relicense it, or find a way to make a connection? I'm actually not joking. You should reach out, because otherwise this very, very profitable thing that lasted over a decade, the IP is still there. I'm just deciding what to do with it.
Cool. So for the next thing, I actually want to talk about your research. And your JAMA network open study became one of the most cited AI medicine papers of the year. This is a very interesting research. Can you tell us more?
Sure. So this was a user study. Hey, doctors, this is ChatGPT just blew up on the scene, right? It's like, well, is that really so good? Is it really so smart? Could it help you make medical decisions? That's what I'm going to be interested in, because now the stakes are getting very high. So it was designed for, hey, doctors, answer very tough diagnostic dilemmas. What's the disease? What do you think it could be? What would be the pros and cons? Stuff. It's not multiple choice. It's much more nuanced than that. But we said, aha, I bet if we give doctors access to GPT-4 in this case, if GPT-4 is shockingly good, it'll make the doctors even better too, right? It's almost obvious. We were just going to do the randomized control trial to prove it because we think it's very compelling. It should shape the direction of how medical practice goes forward. So that was the basic structure. Randomized study, half of the doctors went through these cases, and they had access to the usual internet. So go to Google, go to PubMed, go to Update, just references, you can look them online, but we just told them don't talk to an AI chatbot system. And then the other half of doctors in the study, we gave them access to GPT-4. We just subscribed to ChatGPT Plus and say, here's the prompt, you can go ask it whatever you want. And the surprising results we found for doctors plus usual internet, they actually did pretty well. They got about like 72% on this evaluation. The doctors who had access to GPT-4 actually was about the same. It was like 74%. It was really not that much different, which is really not what we expected. Because if it turns out if you just asked GPT-4 itself the questions, it was getting over 90%, like better than all of the doctors. Even the doctors who had access to GPT-4. This was a very surprising finding, and this was not a fluke. We're not the only ones who have found something like this. This has been shown in radiology many times, and then Google's Omni study, I think, showed something similar to this. Very weird phenomena where human plus computer does worse than the computer by itself on a complex reasoning task. And really question our understanding of like, whoa, wait a minute, this was not what was supposed to happen. There's this fundamental theorem of informatics that's been put forth that human plus computer, when combined, deliver better results than either alone. It just feels so good. It's a very natural mantra. I used to say as a closing line for my keynote presentations for years, and after this study, I don't say that anymore. It's like I'm kind of unsure right now. What does that actually mean? And maybe human plus computer isn't always the best way to do things, or we better figure out how to redesign our system structures and expectations so that it can be.
So what was your team's initial reaction when they got the results?
My first reaction was like, wait, did I just hear that correctly? That the computer by itself did better than both? I looked straight at the biostatistician. Wait, you have to double confirm. That is really true. That is an actual result, and it's not preliminary, and don't need to fix something. Because if it is, that is the headline. That is clearly the headline, but we need to triple check that we can stand behind that to make sure we've done it rigorously. And so once they did, it's like, okay, then let's project the results we can, but really unpack what that means. And it has really led to a whole spawn of research afterwards, because once you have a result like that, you have to follow up on it. Like, well, why did that happen? And what are you supposed to do about it?
You mentioned about your study was done about 2.5 years ago, in which that most of doctors has very little knowledge about AI tools. Do you think the result will change now that many doctors are familiar with it?
Absolutely. It would be the principle, well, that's tricky. On the one hand, things are different now because more doctors are familiar with AI and how to use it, but also the reasoning models and stuff have gotten way better too. So I don't know that you can catch up to them with even some collaborative structure. But it was a distinctive thing. At the time we did the study, a third of the docs in the study, because we surveyed them, had never touched AI chatbot before in their life. They just did not know what it was. Another third maybe used it once or twice, but didn't really know how to use it that well. And so when we studied their logs, what were they actually typing in? It was clear that many of them, maybe half of them, figured out you can copy and paste in the whole story, maybe ask a follow-up question, maybe something that feels normal now. 3 years ago, 2 years ago, that was not normal. People would not have expected you could interact with a computer that way. Many were treating it like it was a Google search engine, which it's not. And then there's another chunk, 10%, who just did not use it at all. What is this AI chat? I don't know what this thing is. I don't know forget it. I don't want to use it. I know how to practice medicine. I'm not going to use this thing. So when that happens, of course, it can't be effective. So I think there's two issues at play. One is, sometimes a computer is just better at computing than a human. Like, I wouldn't compete with a calculator doing division. Why would I compete with a computer at memorizing, medical drugs? That doesn't make sense. A computer can obviously do that better. And so there's some of that. And also it's an education aspect where it was clear that a lot of people using it at the time did not know how to use it or did not trust it. And so they weren't really able to take advantage of it.
Yeah. And you also mentioned about, because this is a very counterintuitive result for many of us, like have human AI is actually worse than AI itself. Do you think this conclusion is applicable to more fields, or is mostly just for doctors?
I focus on the medical context, but the lesson should be very generalizable. We clearly need to scrutinize specific tasks, roles, and aspects where why do we shouldn't always assume a human plus computer is the best solution for certain tasks. I'm trying to think, I don't know, washing your laundry or something. Maybe a human should be in the loop and like move the shirts around. Like, why would you do that? That doesn't make sense. Just put it in the machine, let the automated machine go. That I think we have to rethink a lot of tasks and things we used to assume a human had to be in the loop. It still is needed a lot. We still need humans, by the way. People are going to misinterpret this as we should just replace all workers. That is not what I'm saying. But there are a lot of roles and tasks where we should think, maybe there are certain things we can delegate and actually fully automate in a way with a human on the loop, double checking and being able to support if bugs are coming up, but where we can refocus where our computers and humans spend their attention.
Gotcha. Yeah, I think what you mentioned is also happening in many fields. For example, coding.
Totally.
It used to be co-pilot, like human plus AI. Now a lot of people, they are vibe coding. They just like one prompt and build the whole website. Yeah. Do you think similar things will happen to medical field as well? It's
kind of loaded and controversial, but like obviously yes. It's just kind of where and how and the circumstances by where it happens. There was just recently, I'm sure you have to be careful, right? Because there are some states banning the use of AI for certain health related things. Many Kaiser employees recently just protested and went on strike because they said they didn't want AI being used to be used in mental health kind of support services. Then again, I think like UC San Diego and others, they have, if you call in for helpline, the support line, you'll be talking to AI. You won't be talking to a person anymore. The call center is no longer operated by people. That actually kind of seems a very natural direction for things to go, but you can also see why some people feel very anxious and threatened by these things. Hey, maybe a call center just for scheduling an appointment an AI can handle, but hey, you're asking for mental health therapy support, you have stress or depression, and you want to get advice on how to handle that situation. That sounds very scary, and I get why. I get why. Very legitimately, like very scary, bad things can happen when you just let loose an unproven computer talk to people, and those people don't understand the full implications of what that mean, which is why some states are banning the use of AI for mental health usage. On the other hand, I think it opens up so much potential to reach people, to get access out there who didn't have access to a doctor or a therapist at all, or a counselor in many ways, that I think it's very promising. Predictable pains and literal harms along the way, which is why we have to do a lot of active work to mitigate those and manage that so we can get the benefits while not causing such obvious harm that can happen along the way.
There's many ways that AI can be applied in a very helpful way.
Totally.
And obviously you're also doing some exploration here. Your most recent paper has a very striking title. It's called a From Tool to Teammate. After finding that just give doctors AI is not necessarily a good thing, you started working on some workflow that make doctors more effective with AI. What are the framework?
Sure. This was Eric Horvitz, Chief Science Officer at Microsoft, wanted to do this kind of study. He's done a version of that and got our students, Celine Everett, Brian Bunning, Yvonne Lopez, and many of our team on this one. Because we had that prior result, which was really weird. What? How come doctor with computer isn't really helping that much? It's because, and I can tell you, reviewer number 2 on the first time we submitted that paper, this study is completely unrealistic. No one would just release a computer system for doctors to use without properly training them how to use it first. And I was so frustrated because that is what they do all the time. They definitely will do that. They have done that. We get inundated with tools in the hospital, in the clinic all the time without getting proper training, and we just sort of figure out as we go. And so that I thought was the most realistic study. Here, doctor, here's GPT-4. It's just a public internet tool. You can use it if you want to. But nonetheless, given that, we said, well, a follow-up study is like, what if instead of just GPT-4 by itself, it was a custom GPT in this case that sort of taught the user in real time how to use it. It didn't just say, here's a blank prompt, ask whatever. It said, hi, I'm a helpful diagnostic assistant. If you have any questions about this, you can give me symptoms, you can input, you can ask me follow-up questions. It basically explained to the user how to use it in real time and gave feedback. So it's not just a tool you use, it's like a teammate, or it's more of the co-pilot that's kind of flying with you along the way. And then the interesting things that emerged from that study, and it's just being published right now, a similar pattern. Doctor by themselves with the usual internet does okay, but now the combination of human plus computer is better. It is better, about the same as if you ask the computer by itself. But then now there's 2 different versions of it. If AI is so good at manipulating all this stuff, who should go first? That's an interesting question. Do you have AI write the first draft and then I will fix it and edit it the way I want it? Or do I, as a human, here's my thoughts, AI come in and reformat it, fix it, what do you think? We tried both directions, and both combinations work. The collaboration can be effective and lead to good results in both cases. What's really interesting and leading to a follow-up study we have in submission right now is different kinds of errors depending on who goes first. On average, it ends up about the same, but you have different results because of anchoring bias, sycophancy, right? I'm sure your watchers have had this experience. If you ask ChatGPT, Claude, Gemini the same question 10 times, it'll be a little bit different. And usually these things really, really want to agree with you. They really want to agree with you. And even if you're totally wrong, it wants to like make you happy and just tell you you're right. Because I often say that these systems are designed not to be correct. They're not designed to be useful. They're designed to be engaging. They're designed to make you want to come back, right? This is like social media again. They're designed to be addictive, basically. So you just keep coming back. That is what a business is optimized for, not to be useful. As a doctor, sometimes your most important skill is to tell the patient, that is not the right plan. I'm not going to order that test or that antibiotic for you. And patients hate that. They don't like being told what they didn't want to hear. But as a doctor, your responsibility is also to like do no harm and be thoughtful about what you're doing. These systems aren't designed for that. They're designed to keep you engaged. And predictable harms happen when computer tries too hard to please the user.
Yeah, exactly. I had the exact same experience sometimes when I'm asking the GPT about the questions of my complaint, and we have in this long discussion, and I think the GPT is so reasonable. And then suddenly I said, what if you think the other way around? And the GPT said, oh, yes, you're also right.
Yes. Having said that, a slight tangent here, but I think a very good debrief. One of the really valuable things I found with these chatbots, is like summarize a note, look up information, medical questions. It's fine. It's actually really good at that stuff. But that's almost obvious. What I think is really revolutionary is you can have these conversations and you can practice conversations different ways. So I give the example of like counseling a patient's family. Terrible diagnosis. How do I explain to them? Hey, chatbot, can you pretend to be the doctor and I will pretend to be the patient and have that conversation? It really opens up your empathy. I've done analysis of medical legal cases. Hey, chatbot, pretend like you're the plaintiff. What will you argue? Chatbot, pretend you're the defendant. What will you argue? It's all very interesting. You get a lot more perspective because we all come in with our own biases and looking at things a certain way. That having this has really helped me unpack some complex situations that would have been hard to without the alternatives.
Yeah, exactly. You mentioned about a very interesting usage of these large language models is that it gives you different perspective. It can pretend to be another perspective and have a conversation with you. And you also mentioned earlier on the comparison between this ChatGPT or AI versus the previous generation of AI, which is kind of recommendation algorithms, personalizations. And there are similarity between them, which are both optimizing for engagement. But in the previous generation, you would not be able to switch your views and talk like others. This all comes back to your early points of the human AI collaborations. I think there's some ways that human AI can work and more effective, the example you just mentioned. But there's also some ways that could be damaging in terms of productivity and all other things. I'm curious that from your perspective, what are the several ways that you think human and AI collaboration can be effective? You just gave one example. Do you have other examples like that?
It's all the obvious stuff like paperwork, coding is dramatically changed, right? All my team members, they've wanted, so everyone get on like Claude Code right now. I don't want anybody like handwriting code the same way anymore. It just doesn't make sense. They have to learn how to adapt to this tool. It really reshapes how we can do a lot of things. So those are the very natural ones, kind of counseling, conversational things. My wife talks to ChatGPT like every day, but she's talking about actually her work. It's like, oh, was I too tough in my conversation? How do I manage this person? Like, oh, this interaction, what would they be worried about? How do I think it through? It's all these different dialogues, a thought posture. And it's this kind of thing where it's not that the computer is smarter than you, right? That's not the point. It's often really unloading your ability to understand a problem. You've heard of a rubber duck debugging, right? It's I've got a coding problem. I'm stuck. I don't know what's going on. And you bring in a rubber duck and you just tell it the problem. I would code it this way, and I'm getting this error, and it doesn't make. Wait a minute, now that I'm talking to you, it makes sense to me now. And just having this dialogue partner can really unlock a lot of your own thinking and process along the way. I'm trying to still expand in this way too, but I know more and more using like things like Claude Cowork and others, where you just verbalize what you're trying to do. You give it access to certain files in your computer, and now all sorts of, most of my job now is I just push emails around, right? I haven't actually gotten to write code or really do hands-on stuff, except when I work in the hospital. Mostly I just push emails around. You do this, you do that, fill out this folder, file that one, and I'm just going to make these connections. It would be great if a lot more of that could be automated and streamlined through computational systems, so we can focus on the problem solving, decision making, and interactions and human correspondence, which gets a lot more delicate.
Yeah, exactly. So that's a lot of great use of AI. You mentioned also earlier about the risk of using AI, like anchoring bias, and that could be one reason on that. You mentioned about that. One of the reasons is because they're trained by commercial companies. They're driven by profits. And do you think there are a solution for that? Like, should models be trained by only companies, or there should be a non-profit models, or what is your take on this?
The irony is, for a big question like this, we could just ask AI and it would give a really good answer. Like, I'm thinking really hard how to answer. Like, I should just ask AI. It would have a very good answer to this. It's a dilemma, right? Well, I'll try to have one watch. You could say, well, innovation versus regulation, even though as a general rule, I've been indoctrinated, right? As a libertarian, anti-regulation. I'm not to that extreme, but I think there's a trade-off. I also think, like, if you try to regulate AI as an actively moving object, almost certainly it's antiquated and your approach isn't even effective anymore. But I think there are principles of, it doesn't mean let's just go hog wild and whoever is the most capitalist makes the most money gets to decide the rules. I think it leads to all sorts of very predictable harms. And actually, industrial revolutions like the AI revolution is great for everybody on average. We probably will all be better off in general just because of increased productivity, but it very classically leads to predictable harms, disruption to the way people live, and it greatly exacerbates existing inequities and wealth concentrations and power concentration. So I think we should be thoughtful of that. Okay, that's one angle on the society level, which I actually have concerns about. At the medical health level, for example, they're having some safety guardrails in place. Here's for sure. We're trying to build a lot of benchmarks in our group. Well, here's all these things. If your AI can at least pass all these tests, it doesn't mean it's perfect, but at least we feel like it's not going to do anything grossly dangerous. We have this no harm study right now. It's in preprint, where we found even the best frontier models right now, still 10 to 20% of the time on medical consult cases, it would give harmful recommendations.
10 to 20%?
Yeah.
Well, that's very high.
That's concerning. What's even more interesting there is most of the time the harm is not that it invented, hallucinated some crazy medication or surgery, it told us to do something stupid. The majority is it had an error of omission. So doing nothing is not the same as doing no harm. Very often, like if I say I'm, very poignant example, if I say I'm suicidally depressed, I'm thinking about jumping off a bridge, it would say, oh, thanks for telling me. It's actually very harmful because it's like you need to act on that. It's something very concerning happening. If a patient says they have sepsis, a really bad infection, and you don't recommend antibiotics, or an example I use, if somebody has a sign like they probably have cancer, they lost 10 pounds, they have a new tumor, if you just reassure them and do nothing, that's actually very harmful because you were supposed to follow up and work that up. So defining some of these frameworks, having these benchmarks in place, not the most exciting thing to do, but like a really necessary thing to do because it establishes some safety guardrails so that, hey, if your AIs can at least pass this, it gives them confidence so you can be bold and innovative and push forward. I don't think safety slows down innovation. Safety is what enables you to innovate very boldly and aggressively. Weird analogy, you gotta move fast and break things, right? That used to be the mantra. And you can move fast and break things when you have a very robust unit test suite, right? So that way your infrastructure, is very stable. You won't break anything mission critical because you have a very rapid way to cover yourself and make sure you're still on track.
Is that the reason you lead some efforts on red teaming for the models?
I've been definitely involved in some of those. In so many words, the simple answer is yes. I think there's more nuance of what's red teaming versus what's stress testing versus what's benchmarking, but that broad framework, because that's where I think a lot of the need has been. It's just evaluate what is good, safe medical advice? It's actually really complicated to answer that. What is even good, high quality healthcare? That's a struggle to answer that even for decades. And it's just more pronounced now in the AI era than ever before.
Also, another question I have is that clinical drugs go through very rigorous process, phase 1, phase 2, phase 3 trials. Should AI tools follow the similar patterns?
No, I don't think they should, because it's not the same thing. Then it also gets to this things like, oh, can't the AI explain itself? I'm like, well, nowadays, the language model actually can look like it's explaining itself. But we don't make Tylenol. We don't explain how Tylenol works. We don't explain how anesthesia works, but we still use it. Why? It's because we did the clinical trials. So however this thing works, we have proven that it is safe and efficacious so that we can use it. AI systems in general have never been held up to that level of scrutiny because also like it's a different object. If you can't explain yourself, but we are going to blindly follow the AI to just drive your car, or we have this AI blindly give you medications, yeah, I think it needs to be held up to that level of scrutiny and that level of evidence to know that we can trust that full level automation. But arguably, and this is a gray area, so it's worth arguing about it a little bit, a lot of the AI uses is decision support. Well, just like I consult a textbook, I'm consulting the AI, it's giving my advice, but it's up to me to decide or not whether it applies to my patient. And it's up to the patient or not to decide whether it's the right advice for them. So the liability still falls on the human to be responsible for how to interpret that. We don't subject a textbook to go through clinical trials, phase 1, 2, 3, 4, to prove the textbook is actually safe and efficacious for patients, right? Even though I definitely use textbooks to determine what prescriptions I give to somebody, right? So in that way, you can think of it as a cognitive aid and support. But we are clearly heading towards, I wouldn't have said this out loud 3 years ago, we are clearly heading towards AI doctors, AI computer systems that could like just prescribe medicines by themselves. That would have seemed crazy 3 years ago to even say that out loud. Now, to me, it's obvious, it's inevitable. And in fact, there are places like Doctronic, Legion Health, and Utah has opened up the regulatory sandbox where letting multiple companies try that. Just for medication refills, a relatively safe area, but even that's still pretty contentious about where that goes. And that's not a technology innovation. That actually really is a regulatory breakthrough.
So there's still a lot of things that the regulation and the society needs to learn. But I like your framework of that. If it's decision support, it's likely whoever makes a decision should be responsible. If it's AI doctor, then it's a separate question.
That's a very different standard to expect too. There's a whole depth here. There's software as a medical device. The FDA has some groundwork here. What gets gray, it's like, well, it's just decision support. But what if the thing is, I recommend you get this medication to treat your stroke, and you don't have an hour to think about that. If you're going to do it, you have to do it in the next 15 minutes. And there's no alternative I give you. I'm giving you a single recommendation, and you have to follow this recommendation or not within a very short time frame. That doesn't feel so much like a recommendation. That feels more like a command or an order. I have to do it now. And I think the way the FDA wrote that they would imply that might be under the regulatory purview, and that's not just decision support anymore. But also the latest guidance right now is they said, you know what? Even though we could, we're not going to bother regulating that stuff right now. We're going to try to keep it open-ended because it's really weird tensions. The big tech companies, right? They've got all their frontier models. They said, so if our model says, oh, it looks like you have, I don't know, you have influenza and you should take a flu shot or something like this, that's one advice, and that could be interpreted as too precise a recommendation and needs to be regulated. Well, it's very easy to work around it. We say, you could get a flu shot, or you could take Tylenol, or you could take a hot bath, or they could just make up stupid distractors that are actually making the model dumber, right? It's giving less useful information just to get around this regulation. And so because of that, at this point, and this is changing month to month, year to year, regulatory advice says, you're right. Even though we could regulate you, we're just not going to right now.
So like the regulation is actually it's falling behind.
Well, every human institution is way behind, right? The technology has moved way too fast for our very linearly moving, slow human institutions to catch up, versus technology suddenly erupted at an exponential pace. It'll plateau at some point, but it is very weird. You know, when I first saw GPT-4, I don't know if everybody had this moment like, holy crap, what the heck just happened? I've been in this space for over a decade, and my most famous paper, my most cited paper was 8 years ago. I read about machine learning in medicine. Like, it's great, but it's way overhyped. It's a nice tool, but everyone's like, it's going to change everything. It's like, can help some things. Prediction models do some things. It does not change everything. Versus when I saw GPT-4, I was like, holy crap, this changes everything. Half of my research program, I should just throw it away right now because I was using these types of transformer models. I tested them out 6 years ago because I thought it looked promising. At the time, 35% accuracy in medical questions. Oh, this is stupid. Call me when it gets useful. And this was a fun student project. I just stopped paying attention to that line of technology for a few years until ChatGPT, GPT-4 emerged. Like, holy crap, this got a lot better than it was a few years ago. And that also means it's not that hard to project where we're going in a few years from now, that things are going to advance very rapidly.
Yeah. The technology has advanced a lot in the past couple of years. You mentioned about accuracy used to be very bad, but now with ChatGPT, GPT-4, a lot of progress has been made.
No, I mean GPT-4, that was 2 years ago.
That's 2 years ago. There was a lot of new models, like even this week, Anthropic has missiles and all other models. And LLM has been notoriously known as having a lot of hallucination. With all this progress in technology, do you think this is still an issue?
It's still an issue. It was already clearly a lot less of one. I'm not as worried about it anymore. It's a problem that has to be addressed. And for a high stakes domain like medicine, we must hold it to high standards. But to me, it's like that's an engineering problem. It can be solved and worked on and optimized and measured in ways to specifically address it. That's an engineering problem, not a fundamental science problem. That is clearly already way better than it was 2 years ago, right?
So you are not too worried about hallucination in particular?
It's short term, I worry about it. Long term, I'm not. And also, if this comes up like, energy usage and climate, like short term, it's an issue. Long term, I don't think that's going to be the bottleneck.
From what you see in the long term, what will be the one thing that you would pay attention to for LLM? For specifically the thing that you think LLM will not be able to do well for the clinical research?
That's a big one too that can go in many directions. Some of the themes I talk about are, I've talked about or written. We'll have a perspective piece coming out very soon. Like, what's the point of having humans anymore? What do you even need a doctor for? If even our own studies, and we're not the only ones, many people show, like for many medical reasoning tasks, it looks like these things are smarter than doctors. I'm way oversimplifying, but that's the headline that's going to come across. So does that mean you don't need humans anymore? Well, I'm like, no, obviously you still do. But then you have to rethink, what is it like? Just let the calculator do the calculations. And so now we can refocus where humans can focus on, where you can't rely on a calculator to just do it anymore or ever, right? Because it just serves a different function, and isolating those. And I try to summarize this in competence, communication, and character. Competence, communication, and character. More than knowledge, because am I going to compete with a computer with knowledge? Like, that's a stupid battle. I'm going to lose that battle. There's no point in fighting that battle. But knowledge, and then you have judgment, that experiential learning. Like, why you hear a conversation, somebody's story. You could have looked up the facts. You could have looked up everything on the internet. But like hearing more about what is good, what is bad, what's acceptable, not acceptable, what are worth the risk versus what's not worth the risks. Stats and evidence don't answer those questions. Values and preferences of humans is what you do, and it's being able to identify those. Like, we rely on computers for values, like that's a real problem. That will not lead to good things. You will optimize towards things that look efficient, but efficiency isn't always in the best interest of human values. Communication, empathy is good. Being nice to people is a good thing, but a robot could simulate empathy. A dog could simulate empathy, but many non-physician humans can. But more than that is also influence. Can you direct people in a way that actually is in a positive force for them, which can be a good thing? Danger being LLMs, multimodal generative AI system. It's so obvious they already can fill our social media, our news feeds with AI slop, and be directly manipulated to influence us into politically polarized, dangerous things. And it's already happened. I actually don't have a good answer to that. I'm actually very not optimistic about where that goes in the future. And the present. So
the next part, I would like to learn also your research about the EHR, the medical record.
Sure.
You did some work of like of ChatEHR. Tell us more about that.
Sure. I wouldn't claim my individual credit there. There's a whole team of dozens of people who really pulled that together. Some of that spawned my graduate student, Connor Corbin, years ago. When ChatGPT first came out, the first thing I thought was, I want that connected to my electronic medical record. But I can't do that because of patient privacy issues. You can't just be sending OpenAI all the patient medical records, even though doctors and patients are totally doing that. But I try to write like, you are totally just giving a tech company all your private information. But now through Connor worked with me, Nigam Shah, our chief data scientist, a whole crew here to kind of get the pieces together. Hey, what if we basically create a secure version that could allow that to happen? And then that just spawned, and then we did preliminary testing, and it took years to put all the pipes together. But in so many words, it is basically something like ChatGPT directly connected to the Stanford electronic medical record. So now doctors, nurses, and maybe one day even patients, right now it's only clinical staff, a very common chore or task we have to do is scan through a patient's medical record and find out information. But these records literally can be hundreds, thousands of pages long. Every lab result, every diagnosis code, every note, every patient message. It's actually very difficult, and actually is quite a task and chore. And literally there are people whose job is, like chart abstractors, their job is to just read patient medical charts and try to figure out, do they have diabetes with complication? Do they have a drug injury to the liver? And putting all this information together. Now we can just ask ChatEHR, can you review this patient's chart, summarize in one paragraph, tell me which prior medication they have, what was their cancer history, and what treatments they got? And it is not perfect. It is not perfect. I'm not even sure it's really ready for prime time to make clinical decisions upon. It's in a beta phase, but people are so hungry. So we don't care if it's perfect. Just give it to us right now. We need help right now. Like, okay. And so people were so desperate to get it that we've got it out there. Most of our clinicians have access to it. Enables all sorts of new workflows and ways of thinking and working with complex patient information. Let me backtrack a little bit because I think it's a telling sign. It is imperfect. We're actively optimizing in many ways, our whole broader data science team. You remember the first version of ChatGPT? It blew up, right? 100 million users in 1 month, the biggest thing in internet history. Even though it had a lot of problems. It would hallucinate like crazy. It confabulate all sorts of stuff, give you terrible advice. And I don't know if this is apocryphal, but I had heard the people at OpenAI, before they released it, they were very worried that, oh my gosh, we've been working for years trying to make this general AI system. All we have is this thing. It just hallucinates and makes up references. Oh, nobody's going to ever want to use this thing. This thing is terrible. And then they said, well, let's just release it. Let's just release it and see what happens. And then it turns out, even with its imperfections and problems, it was so eye-opening, the capabilities of things that you could start to do with that. Actually, people couldn't stop using it. So I think that's a similar phenomenon with ChatEHR. It's imperfect. We're improving it every day, but it's useful enough that there's a substantial appetite, demand, and need that people are jumping on it.
Yeah, it's always good to like launch early and iterate fast. One fun story on that, I was actually working on internal version of ChatGPT in Google.
Okay.
And it was hallucinating a lot, and Google decided to kill it. So it never went out in public.
Yeah, it's the same situation. Well, Google was the incumbent, right? The big organization. They don't have the liability purposes. They have to be more conservative versus OpenAI. It's like, well, just swing for the fences because why not? They were the little startup company just a few years ago, right?
Yeah, exactly. Yeah. The next question I have is that now that AI can summarize hundreds of thousands of pages in a minute, right? How does it mean to the medical education system?
This is a different theme. So amongst other things, I'm now the Stanford Director for Medical Education and Artificial Intelligence. This role did not even exist 2 years ago, but our new senior associate, Rena Thomas, when she came in the role, the first thing she asked was, okay, guys, so how many lectures do we have for our students on how AI works? We don't have anything. I mean, I give grand rounds in my seminars, but there's no required coursework for medical students. Like, well, how many slides do we cover it? It's like, no, we don't have like a single slide. We're talking AI. So one of her first tasks was to set up a recruitment, and basically found me at the end of it. She said, Jonathan, like, that's unacceptable. We need to teach all of our people about what AI is, how to use it, and do it effectively. Otherwise, all sorts of problems happen. And it is some real challenges, and there's not agreement on how to handle a lot of this stuff. And I guess I'm here to figure out some of it. Was it 3 years ago when ChatGPT first emerged? The first thing you do is like, try it on some medical reasoning questions. It wasn't perfect, but it it could borderline pass even complex medical reasoning, even at that time. And the first reaction of many people in the medical school around the world, and even at Stanford, is ban the technology. Oh my gosh, don't let our students use this. This is terrible. And the thing they were most worried about was not that the students would be, it's that our tests doesn't mean anything anymore. Our homework doesn't mean anything anymore. It's so easy if a student just use the same, do their homework in their tests, and they don't know how to grade or evaluate students anymore. I think we are fortunately past that phase. Nobody thinks we can credibly ban this technology anymore, but it's got to be. But education's been turned absolutely upside down, maybe even more than healthcare, right? Anything that's based on you have to read and write text, that just does not make sense anymore. You cannot do it the same way. You can't teach it or test it in the same way because it's just so easy for AI to simulate that in a robust way. And I'll give you another concrete example, anecdote that I think really drives us home. I think 2 years ago, our first year medical students at the time, they have a medical reasoning class. So here's a patient case. What do you think the diagnosis is? What the treatment is, right? This kind of stuff. On the homework, students they're killing it. Wow, they're doing great. But then we did the closed book exam in class. Twice as many students failed that test compared to usual. What happened? You guys did so good on the homework. It was obvious what happened, right? They all just use AI to do their homework for them now, and they missed the point. The point of homework is not to get a good score in the homework. The point is to struggle in the homework, and that is what forces your brain to learn so that you're ready for the closed book exam. So that was a very sad end to that story. More optimistically, this year's first year class, I give the first one of these opening lectures for the first years. I tell them intro to AI basically and how it affects their education. I do some magic tricks for them. I also teach them some research concepts, but I'll say, dude, look at this story, guys. AI could be the best tutor and trainer and learning support you've ever had. It really can be. But if you misuse it, it will be the worst thing that undermines your learning and compromise your ability to actually be a competent professional. So if you understand that difference, use it to study anyway. I'm going to advocate that to not ban things, but realize we are still going to test you in closed book environments. And it's not just because of tests. One day you're going to be in front of a patient. One day you're going to be in front of a family member, and you're going to have to make a medical decision on the spot. You can't say, wait half an hour while I go ask ChatGPT. You have to be able to still think on your feet. So this year, the first year medical students actually did better. They actually did better on that medical reasoning exam than usual. Hopefully with this kind of admonition, use AI to help you, not to undermine yourself.
Yeah. And like you mentioned, it's actually very important to set expectation for students how they use AI. But I think for normal students, we have this like tendency of using AI. How do you enforce the proper use of AI in the education?
To me, it's unenforceable. It's unenforceable, right? You have to give the inspiration and guidance, role modeling, and mentorship, which is tough to do at a system institutional level. The first draft of one of our policies on student AI use a year ago when we were trying to formalize it, it was awkward, right? Because I think in our PA, our physician assistant class, there's a reflective writing assignment. So you write something about how you felt about a medical encounter. And then one of the teachers thought, it seems pretty clear the student used AI to just write their essay, their poem for them, because there's too many telltale signs. This is not the way the student usually writes. And when they confronted that student, she didn't lie. She said, oh, I totally used ChatGPT to write that assignment. I didn't know I wasn't allowed to do that. I'm sorry. Was I not supposed to do that? And at the time, they're like, well, technically, we never said that they couldn't, right? If you look at the policy, we don't say anything about AI. Oh, we need to have a policy. And if we didn't get that student in trouble, it was an awakening to the instructors. We need to reframe what expectations we set. So the first draft of the policy was, students, unless your instructor specifically says you can use AI, assume you cannot. And I have fought very hard, like, that cannot be our policy. That cannot be our policy because it is unenforceable. It's unenforceable. Students, you go home and study with AI, but you can't do that unless we allow you permission. Like, how can you stop them from doing that? And some of our other key directors pointed out how that would put our students in a position of undue temptation. And it really puts them in a compromising position in the honor code, right? During COVID, everybody had to do open book exams at that point because you couldn't even come in. It's like, here's the exam, just take it home with you and work on it. And we said, closed book exam, that's what it used to be. It was like, if you're taking the test home with you, there's no way to enforce that. We have to just say it's an open book exam because you can't put the student positions like, you, with your honor, promise you will not use a reference to help you on this test, even though maybe your other friends are and they don't say it. So we can't put students in the same position where you are not allowed to use AI at home unless we say so. that puts a inappropriate position to put them in.
Yeah, it's very hard to enforce. And I think the people also need to use and try to really to get good at using AI.
Here, we try to teach them how to use it, but then I say, caveat though, we will still test you in closed book environments and oral examinations. So use AI in whatever way you think is good. We'll teach you some, but realize you will still be evaluated in ways where you can't depend on it.
Yeah, exactly. Yeah. Another question about AI education is that this technology changes rapidly. Every week there's new things happening. And you are now Stanford's director of AI education. How did you build the curriculum about this technology that is changing like almost every week?
It's a chore. I would really formed a great team. I actually just rushed over here because some of my associate medical directors, Dong Yao, Shiva Fadak, Aiden Zaidavash, and others, I'm just naming a few. There's a broader team here. The first thing that Rena tasked me with this is I need a team to do this because there's too many moving parts and a lot to cover. So some of it, a few ways. It was also a key challenge. It wasn't like, let's just write out the curriculum and then we'll be done. It's like, obviously that's not going to work. The subject is changing too much. So we have a few components. We have foundational curriculum, and these are things I really like to emphasize in teaching. Whatever technology invents, you still need to know what sensitivity and specificity mean. I don't care what technology gets invented. You will still have to just understand what that means. No matter what technology gets invented, our subject is like, do you have to understand what patient privacy is and what you can and can't like upload to the internet, basically. That will be true no matter what it is. How do you weigh risk and benefit? No matter what technology available, that's the thing you would have to consider. And by the way, here's the current tools of the day. We know this is going to be out of date next year. We'll update those 2 slides by next year. And then amongst other things, I'm also the main organizer and host for our Stanford Division of Computational Medicine. We have a weekly colloquia series every Thursday at noon. Usually it's been cutting edge research topics, but now I have some education ones in there because there's update the curriculum for the medical students. It takes another year before they'll ever see it again. And also, but those students are already gone. They already graduated. It's too late, right? So we need a forum where also we can always be talking about the cutting edge topics that keep on changing. And then a whole spectrum along the way. If you want to get deeper, we have med scholars. They can do a summer quarter, do some research. They can do a PhD program if they want. We have also a master's degree, and trying to cater to all the students, trainees, but also existing doctors, scientists, professionals, because it's kind of continuing education for everyone in a rapidly changing world.
I think there should be a lot of flexible ways for people to get up to date on technology. So another question is that I think the whole industry is also, the clinical industry is very regulated. It requires a lot of license and all these things. Do you think that will also change for a person to be qualified to be a doctor? Would that change? Would any AI assisted section included in the licensing exam?
That's interesting. My gut reaction to that is it probably will not change for better and for worse, because a lot of this stuff has nothing to do with technology or efficiency. It has to do with legacy institutions and protectionist guilds who are going to make sure things don't change if it's a way that's profitable for them. That's kind of how human institutions work. They're designed to protect their, sometimes literal unions. Having said that, some changes have already happened in that process. I don't know if you know what like maintenance of certification is. This is to be a doctor, I have to go to medical school and I have to pass a written test. So now I'm eligible for that. And then to be licensed physician, I take another test. And then if I'm board certified in internal medicine, which I am, and every specialty has a different one, not only do I have to pass this test once, it used to be I had to take that test again every 10 years. Oh my gosh, to take this 8-hour test and 10 years later, and it's going to test me all this weird esoteric stuff that I never use in real life. So then they changed it now to like, well, just every 6 months, just answer 30 questions. And then now it's more, it flows a little bit more with what regular life is like. And now it's an open book test. You're taking it at home anyway. If you want to go look something up to date or a PubMed article, like that's what you would probably do in real life anyway. I think just a year ago, they said, well, you could use up to date or whatever, look something up, but you cannot ask AI for help. I mean, I get what they're trying to do, but it's hopeless. It's just hopeless. And I think now they might have given that up. They realize just use whatever tool you would use in practice. Just don't talk to another person. Don't let another person take the test for you. But it's really easy to go through a medical question. I've been doing these, and to ask AI, what do you think the answer is? And even though the AI is not always right, by the way, but it can be very helpful for a lot of these scenarios.
Yeah, in some sense, like you mentioned, it serves the purpose of textbook.
Yeah.
Like,
and to me, that's right, because even your own doctor, do you want your doctor to practice closed book and have to guess everything off the top of her head? You want your doctor to be smart enough to do that most of the time, but I think you want your doctor to be able to say, can I double check my textbook for a second? Can I double check the computer? I'm pretty sure this, but let me see if I can get another perspective to make sure I give you the right information. That should be a good thing that we allow people to practice like this. And why would you want your doctor to be stuck memorizing 1,000 drugs and bugs? That's not what you actually want your doctor for. You want them to have judgment.
Yeah. Cool. The next question I have is that what do you think is the most overhyped AI application in medicine right now, and what is flying under the radar?
I already read about how machine learning was way overhyped. Well, we'll predict everything. We'll predict the day you'll die. I'm like, no, you definitely will not. That is not how any of that works. It doesn't mean it not be useful. So that was definitely way overhyped at the time. What's even hype now? I guess agents are the hype thing. I actually think that maybe overhyped because it's too broad. People don't even know what they're saying when they say agents are going to take over. But I actually think that actually will be very disruptive. But just like the internet.com bubble, which I very much lived through and was a very traumatic experience, it was a bubble. It totally burst, and pets.com led to nothing. And so many companies just like got disintegrated, billions of dollars wasted investment. But the internet did actually change the world. And now every of the largest companies in the world is an internet company, basically. So I'm actually optimistic that more agentic frameworks actually will substantially change and automate a lot of processes and tasks in the healthcare field. But overhyped right now, when people very often, very apropos, people come to me and say, hey, Jonathan, I got this problem. Can you use AI to solve it? I'm like, well, no, that's not how it works. Right? AI is not magic. It's not actual magic. It doesn't just do anything you want it to do. When you understand what it does and doesn't do, and you can understand your problem well enough to see where it plugs in and can be applied, very powerful things can happen. But it doesn't just mean, hey, Jonathan, can't AI just educate our students and just sort of tell them exactly what they should do and give them personalized guidance, sort of, but you need to be more specific, right? That to actually turn it into a real implication.
In some sense, the agents are very, very hyped right now. I think a lot of agent companies. And you also mentioned there are some interesting part of agents as well. I'm curious, what, by your definition, would agent mean to you?
It's funny. I asked my students this. I'm like, can you explain to me? Because I was like, what's the buzzword? And one of them just told inference time scaling. So can you explain that to me? What are these words? It's very much, that's why it's very fun to be at a university, even though I never planned to be an educator. It's like, oh, but you hang around bright students. They teach you and keep you up to date. The simplified way I like to explain it, even though I don't know other people would say it this way, but it helps me conceptualize. In contrast to a chatbot, a large language model, a chatbot says things, right? An agent does things. They have a little bit more autonomy, can actually execute and complete tasks and follow up and plan those. But if a chatbot says things, an agent can do things. The analogy I often like to give is, hey, I'd like to book a reservation at a nice Italian restaurant for me and my wife tomorrow. I don't want to talk about it. I don't want a deep research report. I don't want to be counseled about it. I want someone to just take care of it and just do that. That's the kind of different thing an agent would do that a chatbot would not.
It looks like from your journey, you have been maximize the interestedness, being interesting. I know that other than being an researchers, an MD, and an engineers, you're also a magician. How does that happen?
That's pretty random. That was definitely not on purpose. For better or worse, I've become very known as this. A lot of people just say, do you know there's this doctor who does magic? And apparently people are pointing me as that. That was very accidental. I had, when I was a 12-year-old kid, I think my first trip to Taiwan with my parents, there was the night vendors. You go out to the market and you get a snack or something. And then there's a guy showing a little magic demos. And of course, if you like it, he tries to sell it to you. But I was very captivated, very interested. And my mom bought me this, magic kit, and I dutifully learned it. And it was a fun experience, as many young boys often do. They like to play around with magic kits. But, I did it for maybe a month or two. But then after I showed my sister, my cousins, I had nobody else to show magic to. So it kind of served no points. I kind of abandoned it at that point. It wasn't until maybe 6 years ago, it was just before the pandemic, that I started to get back into it. I was a new faculty at Stanford at the time, and it is really freaking stressful to be a new faculty. We should go back and story about how, by the way, at some point in my life, I said I would never go to medical school. I would never be a postdoc. I would never do medical residency. I would never be at academic faculty because those all sound stupid. Why would you do any of that? I'm going to just go work in industry. The interesting phenomenon is I've ended up doing every single one of those things. But so being a junior faculty is extremely stressful and very unforgiving. It almost feels unrewarding, but you're slaving away, trying to research, applying for grants, and you get almost no feedback, or any feedback you get is usually very negative. Everyone tells you about what you're doing wrong. And it's very damaging to your ego when you're used to being a really smart person who's worked hard and applied yourself and done good work, right? But that's the nature of doing cutting edge research. It is just the norm of how do you maintain that rigor. So where am I going with this? Just try to make my way through that. I started picking up piano again, which I had taken a couple years lessons when I was a kid, and then I just started playing around a little more for fun. I did a lot more in that junior fac phase, and it was almost like therapy for myself. I started learning Beethoven's Moonlight Sonata, third movement, which is way too difficult. But then if I try to learn, who's going to stop me? Who's going to stop me? No one's going to stop me. I tried learning the first 2 seconds of it. That's really hard, but you can learn 2 seconds of the song. Then the next day I learned 2 more seconds. The next day I learned 2 more seconds. The next day I learned 2 more seconds. And after 2 months, I could sort of kind of play it. And that was actually very motivating and encouraging. This thing that seems impossible, extremely difficult, inappropriate for me to even attempt. It's like, well, if I just break it down and do it systematically and just have the perseverance to go through it, actually you can emerge and see progress and make a difference that way. And then so piano, I will play for other people. I mostly play for myself. I'm not that good at it. I'm better than a typical hobbyist. Magic was one. It was a great thing to share with others. My oldest child at the time, 6th grade, was probably 8 or 9 years old. We just happened to be at some street event, and a magician was performing a magic show, and he pulled a rabbit out of a box. And I don't know if you've ever seen a child experience magic. It really is magical. Not the magic, it's to see the child experience. He's like, wow, right? Totally eyes lit up. He comes over, oh my gosh, did you see that? I was like, oh, my child is old enough to appreciate magic now. I'll go buy him a little magic set, just like I had when I was a kid, so he can play with it too, and maybe he'll like that. So I was showing him, my child, how to do some of this basic magic, and I was showing my friend and his son too, just this kid stuff, nothing you would be impressed by. And then what happened? My colleague, he looked over at me and said, Jonathan should work on his sleight of hand. I said, what? What did you just say? I said, I will go learn some sleight of hand magic, and then we'll see how that goes. And so I learned a couple more, slightly more advanced tricks. And then it was also a great icebreaker. First, it was just for my family, for kids, and whatever, just a thing. And then I started showing some students, graduate students, just to show I'm an approachable professor too. And then I actually did it very poorly many times. I messed up many times, but whatever, it's just playing around, just for fun. But then some people kind of liked it. And then I tried a little bit more. They kind of liked it, and I kind of got better, and I got better. And it's like, oh, that's interesting. And it's just spiraled out of control. I've now competed and won multiple magic competitions. I perform live in many venues. I've been paid, I'm very commonly paid to be a keynote speaker now in AI and medicine, and I incorporate magic into the presentation as a live way to engage people. And it's just become this thing that's gone out of control, but has been fun too.
Wow. That's a very fun journey. You mentioned about you learn magic to help you to handle the stress as a junior faculty.
Yeah.
Does it work?
It does, because it's a thing kind of like piano, but what's nice about magic is different, is you can tell if you're making progress. Like sleight of hand magic in particular, many of these techniques, when you first do it 3 times, you're doing it really badly, but you do it the 4th time, the 5th time, the 10th time, you're self-aware, like, oh, I'm getting better at this. And it's actually very motivating to feel that progress and to get some positive feedback from people who are actually enjoying it. So that was a very rewarding and a great way to icebreaker. It's a classic icebreaker for all these like social situations. How many like holiday department parties I've just been sitting at, and I'm an awkward computer nerd. I'm just gonna sit there and sip my drink, but hey, here, I don't know, you want to say magic trick? I don't know, it's just an easy thing to kind of initiate an icebreaker conversation. And then it elevated towards, once you go past, like, here's the secret to the trick. Everyone obsessed with the secret. I bet you have this card there, or I bet you put your hand in your pocket. And like, if you really want to know, you can go on the internet. It's actually not that hard to find out the secrets. The secrets are actually very trivial the most of the time. It is the execution and ability to kind of perform it. And that actually has helped me a ton. And why I get invited for hundreds of keynotes is because it's really sharpened my presentation skills. And when I'm explaining a super complex concept like scientific studies, statistical analysis, understanding medical AI applications and risks and benefits, but being able to phrase like, what is my audience thinking in this moment? Not just here's my data. It's like, if I present this, what will that make them think? But I want them to think that. So how do I present this in a way that guides them there? And that is very much what you have to do when performing magic effects. It's not just go through the motions. If I do this, I bet you're going to think that I had a card up my sleeve, so I'm going to roll up my sleeve. If I do that, I bet you're going to think that I hid it under the table, so I'm going to open up the card box so you see that. You have to really anticipate what another person is probably perceiving about what you're doing.
Yeah. And you had a fantastic presentation skills. One thing you mentioned about is also I'm learning about that is it's very important is to understand the audiences, and which I think made your lecture to be very different than a lot of other researchers who mostly disseminated information out. But you are entertaining the audiences.
I try to, and of course, but it's also part of that is just the fun, but it's also that is the actual trick, right? It's, you're entertaining because you're now paying attention. I can actually teach you something. I can actually inform you versus if I just data dump all the results, like it's just your eyes glaze over, you go back to your email, you're not going to pay attention. But to have that mix and intertwine is a real technique to try to convey important and complex and provocative concepts forward while still be able to capture a human attention, which isn't designed to sit through a lecture that way. So that's been a very, very deliberate thing I've done. It's weird. Before I was already trying to make my talks, my lectures, a little bit fun and provocative. I'd be storytelling techniques. It was just a few years ago, maybe not even 3 years ago, where I first time I had an actual magic trick in my presentation, in my science presentation. And that seems crazy. I think it is crazy, actually. Now it's like totally my signature. People have just told me that is my niche. I have to keep doing it. I thought that was just a phase. I was giving an invited talk to our university medical partners, the clinics affiliated with Stanford. They have a retreat. They wanted to learn about cutting edge topics, but they also wanted to be fun because it's kind of for people to kind of relax too. And it's like, our theme of like magic medicine. Jonathan, we heard you're a great speaker. Oh, by the way, we heard you also do magic, Jonathan. Would you like to also do a magic show in addition? I'm like, yeah, totally. I mean, that's crazy. But another skill I learned is like, this feels very weird, very uncomfortable. I don't know if I'm ready for this. No, you have to say yes. You have to say yes. That's the only way to get better at live performance. You have to just do it as many times as you can. You can practice in front of a mirror, a video camera as many times as you can, and you should, and it still doesn't count until you just start practicing in front of real people. Everything, all the unpredictable things happen. You have to build up with it. So I did that one. And then it was my wife's idea. I blame and thank my wife very much that she had many excellent ideas. And one of her's like, why would you do your lecture, my keynote, and then a magic show? What if like there was some of the magic was within the middle of the talk? Like, what? That's crazy. You can't. If people laugh me off the stage, I'll look like an idiot. I was like, but wait a minute. But I don't know. Let's try. What's the worst that can happen? I look like an idiot and they don't invite me back, I guess, right? No one's going to kill me if I try that. And so that's the first time I tried. And not just, here's a magic trick. Okay, let's lecture. Here's a magic trick. It's like, here's an effect about solving a Rubik's Cube. Very complex problem. Bam, instant solve. But actually, it's just algorithms. Let's talk about how AI is actually not magic. It's actually an algorithm. Can you tell what's real or not? Deep fake imagery is very hard to distinguish. Just like this rope. It looks like this rope just ripped through my neck, but obviously it didn't. So can we understand and break down the solution? Mm-hmm. And it ended up being remarkably effective and successful. And that was really maybe one pivot point in my career where like, this could really be a thing. And I've certainly turned that into a thing now where I try to educate, reach out to people, but directly incorporate these type of techniques to engage them on a complex topic.
You did mention about it is the positive feedback that help you to learn, have a much smoother and fun journey as you learn magic tricks. Do you think there is an issue right now in our education system or our society as a whole that give too many negatives to students with ambitions?
It's a very, very broad question. I don't think I have a one simple answer to that, because the reality, even doing magic, I've gotten plenty of negative feedback all the time. There's something very inherently adversarial about doing a magic trick, even though it's not supposed to be. It's supposed to be like, I'm just doing something for fun, so we have some joy together. But I work with a lot of engineers and doctors, very analytical thinkers, and they're, oh, how did you do that, right? I bet you they get, some people get angry, and they get, and I caught you, I saw that card there, and it's like, yo, I'm trying to just do something for fun. But that negative feedback is like, oh, if I internalize like, oh man, I messed up, I'm terrible, I'm an idiot, which sometimes I still have those feelings, by the way, I'm just a human, or I said, oh, I'm going to make a note of that. I literally have a spreadsheet of thousands of rows every time I've tried to perform something with notes on like, I should probably fix this and make it improve that. Within the educational framework, I don't think that should be just, we should give all positive or negative feedback. We should calibrate and steer and give people opportunities to help them actualize and realize what their strengths and aspirations can be. Otherwise, it doesn't help them either to blindly direct people to something that isn't really what they're going to thrive in.
So the next question I have is that I want to take a step back of your own journey, because you went through the journey in the early days in which the medicine and computer science are completely separate fields. And you were one of the early people who basically pursued both as your interest. And now it comes all together. And for a young people who has a similar combinations of interest like you do, CS and medicine may be different things, different combination together. What would be your advice to them?
There's a few things I want to touch on. It's like, am I early? I'm just relatively early. A lot of people were doing this kind of stuff 50 years ago, before I was born. AI applications in medicine is always where people want to apply, because that's where it matters and the stakes have been done. And so medical informatics, Ted Shortlift founded a department here, the division I'm in now, basically. Was it before I was born, or was it around when I was born? So a lot of that's been there. A lot of compelling ways to do it. Some of the lessons I might say I've already said, which is the most impactful people have strong quantitative, technical, real hard skills, but who also deeply understand a subject application domain. And it's going to feel like those are competing goals. Whatever, that's just applied science. That's just, I want to do hardcore the math and the fundamental algorithm. You can and should do that. That actually is really cool. And if that's what gravitates you, you're excited by, you should do that. But if you can find a way to actually do some of both, that can be very compelling. But it's tough, right? But don't force yourself to learn or do something that you hate doing, because it doesn't get better later. You just get to do more of what you're doing. So if you hate what you're doing, do something else. Find something that is productive, useful, and valuable, but that you actually find rewarding along the way. I think would be some good principles to think about.
That's cool. That's cool. And do you have any advice on the resources or information sources people should check out?
We're part of a broader Arise network, we call it. Stanford, Harvard, multiple other sites, where it's just a collaboration, mainly the research we work to do. We try to collate a lot of our research and our processes, but we also have a mailing list. So you can check our computational medicine colloquias every Thursday. We're always talking about updated topics. Reach out to me if you have a suggestion for one that would be compelling for the community to learn from. And then we have our AI med-ed curriculum, the things we're trying to teach any doctor, any student, every professional, what you should know. And then we're making all this available online as well. But it's just unending resources. The issue is not what to resource. The issue is how are you ever going to find time to digest them all? So also, if you want to use Notebook LM or something to digest them for you, you should probably do that. You should probably do that.
Right. Thank you. Thank you very much. Really great to have a conversation with you, and appreciate you sharing with our audiences.
Thanks for having me. A great conversation.
Thank you.
Thanks for watching the full interview. Don't forget to subscribe to our YouTube channel and turn on notifications so you never miss the next one.